Welcome to another episode of AI 10X brought to you by 10 Leaves. So today we're doing a deep dive that, it really hits at the absolute core of our existence. The air we breathe and the water we drink.
Yeah, non-negotiables.
Exactly. They're essentials. And the source material we've pulled together shows AI moving from, a specialized tech tool to something more like an indispensable global guardian for both.
That's the crucial framing for this whole dive, because historically our methods for, say, ensuring clean air or safe water have been almost entirely reactive.
Right. We wait for something to go wrong.
Exactly. You wait for a bad report, you pull a sample, you send it off to a lab, and then hours or days later, you start the cleanup.
So this is about a fundamental shift.
It is. The shift that AI enables is moving these critical systems away from that reactive cleanup model to one of proactive protection.
So it's like we're moving from driving with only a rear-view mirror to having a predictive weather forecast for our entire utility infrastructure.
That's a great way to put it. That foresight is everything.
Okay, let's unpack this then. How?
Yeah.
How exactly does AI help purify air and water, according to these documents? What's the core mechanism here?
It all starts with sensor data. Think about it. Every treatment plant, every pipe network, every urban air quality monitor.
They're all covered in sensors.
Covered in them. And the core thing AI does is analyze that constant, massive stream of data. Everything from particulate matter in the air to, chemical pH and flow rates in a water system.
At a speed no human team could ever match.
It's not even in the same ballpark. It's completely impossible for a human team.
Right, so that's the crucial difference then, because we've been gathering this data for decades, but it would just sit there until
an analyst could get to it, or until a physical sample came back from the lab. What AI does is interpret that data in real time.
We're talking about instantaneous detection.
Precisely. And that's a monumental leap. In a traditional system, you pull a water sample, and it might take hours, maybe a day, to confirm a contaminant.
And during that time, the contamination is still moving through the system.
And the risk just escalates.
Mhm.
Exactly. When an AI model is constantly looking at that sensor output, it spots these tiny little anomalies that signal trouble immediately.
What's fascinating here, I think, is that the speed just changes the entire game.
It does. It enables a near instantaneous, often automated response. If a sudden surge of industrial discharge hits water intake or, a localized cloud of harmful particles like that PM 2.5 stuff appears in a city.
The AI flags it in seconds.
In seconds. And that speed, that allows for prevention, not just mitigation.
You stop the problem from circulating in the first place.
You shut down the intake, you reroute flow, you move from a messy, expensive cleanup job to a proactive defense. It's a completely different mindset.
And to make this a bit more concrete for everyone listening, the sources seem to highlight two primary areas where this is already making a huge difference. One, like you said, is identifying harmful particles in the air. So cities can issue these super localized warnings or even, automatically turn on filtration systems in a school or a hospital.
And the second, which is maybe even more critical for health, is detecting tiny chemical imbalances in massive water systems.
And we're not just talking about bacteria.
No, not at all. We're talking about monitoring for things like microcontaminants, trace pharmaceuticals, complex industrial solvents, things that traditional systems often miss entirely.
Or they detect them way too late.
Way too late. A tiny, otherwise invisible shift in alkalinity is the fingerprint the AI uses to say, hey, something's not right here.
So the AI is this incredibly vigilant watchdog. It's not just looking for big red flags, but for these subtle shifts a human might miss until the damage is done.
Exactly.
Okay, but this is where it gets, I think, really interesting. The sources say the real value is moving beyond just detecting current problems to actually predicting future ones.
That's the major leap. It's from vigilance to true foresight. Once an AI gets good at interpreting real-time data, it starts to integrate historical patterns, weather forecasts, even traffic data to build these predictive models.
And the sources point to two big benefits that flow from that.
Two huge related benefits. Yes.
So let's break those down. First is the prediction of the contamination events themselves.
Absolutely. The AI models can anticipate when and where a problem might pop up before it even happens. For instance, a model might learn a specific pattern, say a multi-day drought followed by a heavy, sudden rainstorm near a big agricultural runoff zone. The AI knows that specific combo almost always leads to a huge spike in sediment.
So it connects these seemingly unrelated things, weather, geography, and says, okay, in 36 hours, Our water quality is going to breach the threshold if we do nothing.
That's it, exactly. And that advanced warning changes everything, which leads right into the second big benefit. You can optimize the filtration systems proactively and efficiently.
You don't have to wait for the problem to hit.
No more frantic reactive scrambling, which is incredibly wasteful.
It almost sounds like instead of running a treatment plant like a car that's just floored all the time.
Wasting fuel, right?
Yeah, wasting fuel just in case there's a hill. The AI is like a smart cruise control. It sees the hill coming and applies the power right when it needs to.
That is a perfect analogy. That's exactly it. That foresight leads to much, much better resource management. Think of the energy needed to run pumps, UV filters, all of it.
It must be massive.
It is. And traditional systems often run at a constant high level, just in case, for the worst case scenario, 24/7. AI lets the system run at a lower, more efficient level most of the time.
So it saves energy for 90% of the time, and then based on that prediction, it can automatically ramp up for the 10% it's actually needed.
And that automatic adjustment is the ultimate goal here. The human oversight part starts to shrink, so managers can focus on long-term infrastructure health instead of just constant crisis control.
So the system itself can change chemical dosing or increase flow rates through a filter, all based on a prediction made days in advance.
If we connect this back to the bigger picture, it means less water wasted, less energy used, and huge savings on costly chemicals. It's about preventing problems before they even start.
And it builds trust, I'd imagine.
It absolutely builds trust. The second people feel their water or air is unreliable, confidence in public services just plummets. This helps guarantee that consistency.
Okay, that makes perfect sense. So let's pull back a bit. This is clearly about more than just efficiency metrics. What's the long-term impact of this kind of AI integration on a, societal level?
Well, the sources really paint a picture of a future where this kind of intelligent infrastructure fundamentally changes the relationship between our cities and our natural resources.
In what way?
When purification systems are this proactive and adaptive, the results are cleaner cities, healthier ecosystems, and just more resilient infrastructure overall. You're engineering resilience into the system from the ground up.
Making our essential services less vulnerable.
Less vulnerable to environmental shocks, yes.
But I noticed the sources really stressed that this isn't just an efficiency tool for, stable, well-funded countries.
Oh, not at all. In regions that are grappling with chronic pollution or complex industrial waste or escalating water scarcity, these systems become tools for survival.
Public health stability.
Absolutely. Think about rapidly developing areas where the infrastructure just can't keep pace with population growth or environmental degradation. In those places, waste isn't an option, and contamination can be a massive crisis overnight.
So it's basically giving our infrastructure a brain, the ability to adapt to environmental pressures in real time.
You're making concrete, steel, and pipes intelligent enough to respond to everything from a drought to a toxic spill instantly. And this raises, I think, an important question that summarizes the mission here.
Okay.
AI isn't just about a small incremental improvement. It's about creating a fundamentally safer world by building infrastructure that is just smarter, more robust, more adaptive to threats. It sees the threat before it arrives and acts on that foresight.
So when we boil this all down, what's the key takeaway for someone listening? I mean, if we recap this deep dive, AI is the engine that's moving purification from reactive cleaning to proactive prediction.
Right. From spill cleanup to spill prevention.
It uses real-time sensors to spot contamination early, and then it optimizes the whole system, saving energy, saving resources. And the end result is cleaner cities and healthier ecosystems.
Yeah, and maybe the final thought to leave everyone with is this. AI gets a lot of headlines for consumer tech, software.
Right.
But its quiet, essential application in environmental stewardship might be its most critical contribution. The sources suggest AI isn't just powering innovation, it's actively helping protect the planet we depend on.
Which makes the technology fundamental, not just for efficiency, but for
survival.
For long-term environmental balance and human survival. Exactly.
This was an episode of A10X presented by 10 Leaves.